Every few months, someone says the AI boom is running out of steam. And every few months, at least so far, the market proves them wrong. But even though AI is still growing fast, at some point, it won't feel like the brand new thing anymore. That's why investors are already asking, what comes next? Some are looking at robotics, some are betting on nuclear, others think quantum computing is where the real breakthrough will happen. And there's a case for all of them. But there's another sector starting to move into focus. One that could become crucial to computing, data centers, and even the future of AI itself. And most people have still never even heard of it: photonics. Depending on how broadly the sector is defined, estimates place the global photonics market around the $1 trillion range, with forecasts calling for continued growth through the 2030s. For instance, the global photonics market is already estimated to be around $1 trillion today. Some projections put it above $1.3 trillion by 2030 and close to $1.9 trillion by 2034. So it's already big and it's growing. But size alone doesn't make it a great investment story. If photonics really is the next big sector to watch, we need to understand why. But first, what even is it? Here's the simple version. Photonics means using light. Electronics moves information with electricity. Photonics moves information with light. And even if you weren't familiar with the word, chances are you already know the technology. Fiber optic internet, lasers, Face ID, barcode scanners, medical imaging, LiDAR, that's all photonics. So it's already important today. But the broader market is only one part of the story. The more interesting piece for investors is a faster growing niche called silicon photonics. While the wider market is projected to grow steadily, forecasts show silicon photonics growing from just over $4 billion in 2026 to more than $22 billion by 2034. And it's all thanks to AI. The problem is right now, AI is hitting a physical wall. Modern AI runs across huge data centers packed with GPUs, servers, switches, cables, memory, storages, and cooling systems. All of those parts need to move data back and forth constantly, and that demands huge computing power. For decades, most of that has been built around electronics. Signals moving through circuits and data moving through copper, but copper has a speed limit, and when you push AI scale amounts of data through copper really fast, it creates a lot of heat. This is already one of the biggest pressure points for AI. Companies are spending fortunes building data centers, then spending even more trying to keep them from melting. The International Energy Agency expects global data center electricity use to more than double by 2030, reaching around 945 terawatt hours. That's slightly more electricity than Japan uses today. And that's a problem. But it's one photonics promises to solve. Because instead of pushing electrical signals through copper, photonics can move data as pulses of light. And that physical shift allows data centers to move massive amounts of information at much higher speeds while cutting down on wasted power and heat. A big way it does that is by building light-based components right next to the processor through silicon photonics and co-packaged optics. That shortens the electrical part of the journey, so data can move faster and more efficiently. And if AI keeps getting bigger, efficient data movement will only become more important. That's the core bull case. Photonics is likely the best way to achieve that. But the opportunity isn't just limited to AI and data centers. The exact same technology is driving autonomous vehicle sensors, 5G networks, and advanced defense systems. It's even crossing over into another rising sector: quantum computing. It's another hot problem. Current quantum computers need to be kept at near absolute zero to function. That relies on massive, expensive cooling systems. But because light is naturally resistant to thermal interferences, researchers are now exploring photon-based systems that can operate at room temperature. The short story is, by scaling photonics for AI today, the industry may also be building the hardware foundations for quantum computing tomorrow. But for investors, the near-term case is much simpler. AI needs more bandwidth, less heat, and less wasted power. Photonics is trying to deliver exactly that, and the money is already moving. In 2026, Nvidia invested $4 billion into Lumentum and Coherent, two major players in optical technology. The deals include roughly $2 billion for Lumentum and $2 billion for Coherent, along with long-term purchase commitments for advanced laser and optical networking components. That matters because these components are part of the supply chain needed for silicon photonics, co-packaged optics, optics, and other light-based interconnect technologies. In other words, Nvidia is not just buying more GPUs, it is trying to secure the optical infrastructure needed to connect those GPUs at massive scale. And when Nvidia starts writing checks of that size, the market notices. Marvell also closed a multi-billion-dollar deal to acquire Celestial AI, specifically to bring high-speed, light-based connectivity directly into its chip architectures. And there are private companies too. Names like Lightmatter and Ayar Labs have already raised nearly $1 billion combined, with backing from industry giants like Nvidia and AMD. In the GPU world, Nvidia had a massive monopoly. Photonics is much more fragmented. The winners won't necessarily be the companies with the most hype. They'll be the ones whose technology becomes part of the default standard for the next generation of data centers. But remember, for every winner in a tech cycle, there are plenty of losers. Trying to pick a single winner in an emerging sector is a dangerous game. One bad earnings report, one failed product, or one better competitor can wipe out your gains overnight. This is why for most investors, picking individual stocks in a sector like this is high risk. But if you believe in the sector and want to sidestep that all-or-nothing risk, ETFs can be a useful way to do it. Instead of betting on one company, you buy a basket of companies across the photonics supply chain. Although pure-play photonics ETFs remain limited and should be checked carefully for holdings, liquidity, fees, and actual exposure, the Tuttle Capital pure-play photonics ETF and the Corgi lithography and semiconductor photonics ETF are two recent examples. Both launched in May 2026 and have already pulled in hundreds of millions of dollars in capital. But even though ETFs can help manage risk, they don't eliminate it. For photonics, there are still major hurdles. The industry is still finding its footing, manufacturing these components is difficult and expensive, mass production is still a work in progress, and companies are racing to improve yields to a profitable level. There's also an integration problem. Every data center operator has its own setup. If a new optical component doesn't fit into the existing architecture, or if the cost of the transition outweighs the energy savings, adoption will slow down. Plus, this isn't just about AI. A lot of photonics companies are still tied to traditional markets like telecom, industrial demand, and consumer electronics. If those sectors drag, it can hurt the bottom line. Even if AI demand is strong, ultimately, the question is not just whether photonics is the next big thing, it's whether the current architecture of AI can even survive without it. It needs more bandwidth, less heat, and more efficiency. Photonics is one of the only ways to scale past those limits. Whether the market rewards that insight today or 3 years from now, the physics of the problem aren't changing. And for investors who understand that before it becomes the obvious story everyone is chasing, that's exactly where the opportunity could be. So, what do you think? Is photonics the one to watch, or is there another sector you're paying closer attention to?